Question 1, cool one. Press pause, let's get a piece of paper. Let's write this question down on advanced ratio and show you the tips and tricks for handling this question in the higher paper. So let's attempt it and press play when you are ready. Okay, a bag contains red and green shapes in the ratio of 4:5. Okay, so there are two different, let's say, categories over here. Two different outcomes, red and green. The red shapes have circles and squares in the ratio 3:2. So already we're looking at a different type of, let's say, a category over here as well. Okay, you can divide the reds into circles and squares. The green shapes have circles and squares as well in the ratio 3:7. So both the reds and the greens have the same types of, let's say, shapes, i.e. circles and squares. Find the probability of picking a circle. So this is a good technique. We use tree diagrams to represent advanced ratios. Let's explain what we mean. So we don't have to do it via tree diagrams, but this is a typical scenario where we could. So how many outcomes are there first of all? How many different categories are there? They're red and green. So first of all, let's do our first leg. We call this a leg over here. The first, let's say, pick, or the first leg, red and green. We'll call this R for red and G for green. Now this is in the ratio of 4.5. So for every 4 reds, there are 5 greens. So we could say this could be 4/9. And this could be 5/9 as well. Okay, that's the ratio or the converted fraction from that. It doesn't mean that there are 9 altogether in here. It just means the ratio will always be 4/9 and 5/9 respectively. So our second leg could denote our second category over here, which are the different types of shapes, circles and squares. So we could have another 2 outcomes over here for the shapes. So the first leg are the colors, second legs are the shapes. So circles, I'll just draw a circle. In fact, it might be easier. Circles and squares, circles and squares. So let's look again. The red shapes have circles and squares in the ratio of 3.2. So hence, the circles over here, the circles represent 3 for every 2 squares. So this is 3/5. And this would respectively be 2/5 as well for the squares. Now the circles for the greens have circles. For every 3 circles, there are 7 squares. So this would be 3/10 and 7/10 as well. Make sure they add up, by the way, to 1 on each of these branches over here. Now we can attempt this. So find the probability of picking a circle. So the circle is obviously on the second leg over here. Circle is over there. It could be anything in the question. You could ask you a square. We've picked circle over here. That's why it's good to draw a tree diagram. So how do we get to the end of this? The second leg, we times them. So to get to a circle, there could be either red circles or green circles. To get a red circle, it would be this. It's the probability of a red circle over here. Red circle, that makes sense. R and circle, that is, not R and O, would be 4/9 times 3/5. Okay, that would give us 12/45. Now that would be this one over here, by the way. If we point to that over there, this one over here, this would be the probability of getting a green and a circle as well. Okay, GO. This would simply be 5/9 times 3/10. It's nicely represented in this format. Okay, 15/90 is the probability you'd get a green circle. So it could be this or this. What does or mean, or either? It means to add. We're going to add 12/45, non-calculated by the way, plus 15/90. Let's get this, multiply this by 2. So this is the same thing as saying 24/90. Okay, plus 15/90. The answer is 24 plus 15. This would give us 39. 39/90. That would be the probability of picking a circle. So every 90 times you do this, 39 would be a circle. So look back at this question, look and understand how we create a tree diagram, what we're looking for specifically to do this. But that would be the answer for this, 39/90. Question 2 challenge. So press pause, write this question down, press play when you're ready. So this question is all about enlarging a shape with this center of enlargement, which is not 0, 0, i.e. center of enlargement 0, -1. So our 2 key buzzwords, scale factor -1.5, this 0.5 is propped up, and center of enlargement not 0, 0, which are making it slightly more difficult and more challenging in this case. But not to worry, let's see what we can do. So step 1 is obviously to label our points A, B, and C. It doesn't matter where you label A, B, and C. A we'll do over here, B over here, and C over here. Step 2, we've done this already. Create your construction lines, please. This red construction lines through the center 0, -1. And the third part, let's decide if this is a 0, 0, center 0, 0, or 0, -1. It's 0, -1, which means we have to create a new kind of table to understand this. So let's have a look at this. So we're not going to look at the coordinates of A. We're going to look at the actual relative position it is from the center of enlargement. So let's say if A is over here. Okay, now A is relative to the center 1, 0. Okay, that's the relative position, i.e. the translation to get from the center to here. Now, if you were to times this by a scale factor of -1.5 here, so let's put SF minus 1.5, we're going to get an answer of A dash, and A dash will be 1 times -1.5 is -1.5, and 0 times -1.5 is simply 0. -1.5, 0 from the center will be -1.5 back here, and 0 up or down, it'll simply be over there. That's A dash. The same thing we're going to be doing for B. So B is defined from the center as 1 across -2. Okay, 1 across -2 is the relative position from the center. So I'll write 1 -2. Your scale factor will obviously be the same for this, -1.5. If you times 1 by -1.5, we're going to get again -1.5. If you times -2 by 1.5, we're going to get an answer of 3. So -1.5 from here, -1.5 back and up 3, 1, 2, 3. This is B dash over here. For C, we've got C over here. Its relative position from the center is 3 across and 2 down. Okay, so 3 across here and 2 down. So we have 3 and -2. The scale factor of, again, -1.5 for this one. You times each one of these by -1.5. So this 3 times -1.5 will be -4.5. And -2 times 1.5 will give us simply 3. If you go -4.5 on here, 1, 2, 3, 4, -4.5. Back and 3 up, 1, 2, 3. It's going to be just shy of this line. This line should have been drawn a bit lower, I would say, but this is the true point. We'll call it C dash straight away. And then this is the new shape. We simply join them up before we lose track of this. So it's going to be from here to here, here to here, and here to here. So to make it slightly clearer, let's just color this in a bit. But this will be your enlargement of scale factor -1.5 and center of enlargement 0, -1. And so I hope this table helps. It's a translation from the center that's so important. It's not the relative, it's not the coordinate, it's the actual relative position that counts. Try to find X and Y and press play when you have finished. So again, we're trying to find out X and Y over here, and we've got two different equations. One's a linear, one's a quadratic. Now this looks a bit different, this linear equation. Why? Because we're not showing X or Y explicitly over here, meaning X is not the subject or Y is not the subject by itself on the left hand side. So what we're going to do is create a new equation, number 3 we'll call it. We'll call this L, and we're going to make X a subject over here. And the reason why we're making X a subject is because it's a bit hard to divide by 2 if we were to make Y the subject, okay? So, but in theory, it doesn't really make a difference if it's X or Y. So this is our new equation over here. We're dealing with this one, quadratic, and this one over here, a linear. So number 1, let's do this. Let's write these 3 steps down, in fact, over here. So number 1, the first step is to substitute the linear into the quad. Okay, we'll call this one over here green. Okay, and we'll do step 1 over here. So linear into quad. So wherever we see, let's say, the X over here, we're going to substitute the X we see in here. We'll put a bracket as well. So number 1, 2, 1 minus 2y, and we'll do 1 minus 2y again, okay, because it's squared. I did 2 steps in one, by the way, plus y squared equals 4. Let's now multiply these brackets out over here. Crab claw, 1, 2, 3, 4. Another way of doing this is to multiply this bracket by 2 first of all, and then that answer by 1 minus 2y. But either way, it doesn't really make a difference as long as you get this answer right over here. So this will be 1 minus 2y plus 4y squared plus y squared equals 4. So this is 1 minus 4y plus 4y squared plus y squared equals 4. Let's multiply everything by 2 now. So it's 2 minus 8y plus 8y squared plus y squared equals 4. So let's try to form a quadratic now, okay? So all the y squareds, we have 8y squared plus 1y squared, 9y squared. All the y's, we have a minus 8y over here. And 2 take away 4. Look how I'm taking the plus 4 to make a minus 4. So 2 minus 4 is minus 2 equals 0. So step 2 is to form a quadratic. Okay, it doesn't have to be a quadratic all the time. It could be half a quad. You come across that term before. It could be a normal equation, but this is a quadratic most of the time. Okay, we'll call this one over here yellow. Okay, so this is forming a quadratic over here. Let's solve it as well in step 2. Okay, so you want two numbers to multiply to get minus 18 and add up to get the middle number minus 8. Now, can we do this? It's a bit hard to do, so we're going to be doing something else over here. We're going to be using the quadratic formula when you can't do it that way. So let's just split this up to make it easier. Let's carry on with step 2 and let's try to solve this quadratic. So a equals 9, b equals minus 8, and c equals minus 2. So we won't go into the detail of how we go about the quadratic formula. That's another chapter in itself. But basically we'll end up with this 8 plus root 136 all over 18. Okay, so that's the quadratic formula. If you plug that in, we're going to get a value of y of 1.09 to 3 significant figures. Now let's do the same thing, but a negative one over here this time. So 8 minus root 136, the whole thing over 18. And the answer this time, the other y value, would be minus 0.2, again to 3 significant figures. So these are two different y values. So let's find the corresponding x values now. Okay, let's sub this back into number 3. Okay, number 3 on our original equation over here. So we'll call this a blue over here, and we'll call this 3. Our third step is to sub this in. Okay, so 3 is over here. Let's do it over here. So the corresponding x value for this one over here, okay, would be this one over here. So let's call this actually y1 to make it easier, and y2. So let's find out x1. Okay, so x1 would be 1 take away 2 times 1.09. Okay, and that would give us an answer of minus 1.18. Okay, and x2 similarly would be 1 take away 2 times this one, by the way, minus 0.2, and that would give us an answer of 1.4. So these are our answers over here. We've got, if you can see this, you've got two different sets of coordinates. You've got your y1 here, x1 here, y2 here, x2 here. If you wanted to, you could write this in a more concise way over here. I don't want to confuse you, but I'm going to write the answer over here. So the first coordinate would be minus 1.18, comma, 1.09, x1, y1. And your second coordinate, x2, would be 1.4, comma, minus 0.2. So there you have it. Those are your final answers, your two final coordinates. Again, look through this grade 8 question, okay, because there are lots of things to master in this, but that would be your blue one over here for substitution, your third step. Circles and tangents. So let's kick off this session here with these exam style questions on these mainly grade 8 questions. So we need to be experts in tangents and circles, identify these and identify the questions more importantly. So let's write this question down and press pause, press play when you have finished. Now let's read this question. So here is a circle center 0 over here. The tangent to the circle is at the point 3, 2. So that's the tangent over here. And this is the point P over here. Find the equation of the tangent at the point P. So this is very, very simple, this question, in terms of the steps needed for this. So we recommend you write this or take note of the steps over here. So first of all, we have a tangent over here, a linear line, and this is your circle, okay? Let's first of all find the equation of this radius over here. So we're going to draw a radius, and the radius is from the center to this point P. We'll call it the green line over here, and let's try to find the let's say gradient of this, because if you know the gradient of the radius, you can find the you can perp it, which means perpendicular it, and find the gradient of this tangent. So step 1, we'll find the gradient of a radius. So let's think back what you know from this. The gradient is obviously y2 take away y1 over x2 take away x1. This is a very basic understanding. You don't have to do it this way, okay, but just to give you an idea over here what we're talking about. So this is 0, 0. Let's call this x1 and let's call this y1 over here. We'll simply call this 3 is equal to x2 and 2 over here is y2 over here. So y2 is 2, 2 take away 0, all over, let's say x2. X2 is simply going to be 3 in this case. 3 take away 0. It's very, very simple. The answer would be 2 over 3. So the gradient of this is 2 over 3. Okay, of line OP, it's 2 over 3. Okay, let's now find out. Let's FM it. FM means flip and minus this. We want to find the gradient of this perpendicular gradient, i.e. the tangent. So number 2, we're going to do the gradient of the tangent. Alright, so to do that, we've got 2 over 3. We have 2 shortcuts. Let's FM it. FM means to flip. F for flip. 3 over 2. And then we'll M it over here. We'll minus it. Minus 3 over 2. So this line, this tangent, has a gradient of minus 3 over 2 over here. That's the tangent. Step 3, the final step. Let's substitute in a value into our tangent. Now, the only value we have is this coordinate P. So let's substitute 3, 2 into a tangent. Alright, so look at this carefully over here. Let's actually color coordinate these so we know what we're talking about. Let's call it this one X. We'll call, let's say, green. And we'll call the Y. We'll call, let's say, this beigey color over here. Alright, so let's sub this into Y equals mx plus c. That's what we want to find out. So we've got Y equals mx plus c. Now m is minus 3 over 2. That's your gradient of the perpendicular, or tangent, should we say, plus c. Right, so y and x. Let's plug in y and x over here. So again, this is going to be x over here, and the y will be this beige one over here. So y is simply going to be 2. 2 equals minus 3 over 2 times x. X is 3. We'll put this in brackets. This is a non-calculator, plus c. It's good for you to identify which is which. So again, clearly we'll mark this is going to be x over here. X is 3 and y is the 2 there. All right, let's do the brackets first and let's figure out what this is. So we've got 2 equals minus 3 over 2 times 3 over 1, let's say, plus c. Now this is 2 equals top times top is minus 9 over 2 plus c, and therefore to find out c would be 2 over 1 plus 9 over 2. All right, which simply would be let's say a big 2 over here. 4 plus 9, this is back to basic fractions, which would equal basically 13 over 2. So C would equal 13 over 2. Therefore, the equation would be y equals minus 3 over 2 plus 13, that's an x as well, 13 over 2, your y-intercept. If you were to think of it like this point over here is not to scale, obviously, would be 0, 13 over 2, 0, 6.5 up, which makes sense. If that's 6.5, this is 5 over here, that would be 6.5, 1.5 higher than that. All right, so that's your final equation. That's your tangent. Those are your 3 steps for this. Make sure you understand that. Write that down somewhere because this is so important to understand. Step 1, gradient of radius. Step 2, gradient of tangent. Step 3, sub it in. This is your final tangent over here. And also you could write it like this if you wanted to. Because we have the same denominator, you could write it like this. Depending if the question would require this, you could say this would be simply y equals 13 minus 3x, and the whole thing would be over 2, because one big denominator of 2 is probably easier on the eye to recognize. So that could probably be your second answer as well, depending on what you wanted to do. There we go. Advanced probability tree diagrams. So press pause, let's write this question down and do your best. Press play when you have finished the answer. Now, there are only blue and yellow counters in a bag, 2 different color combinations. The ratio of the number of blue counters to the number of yellow is 1 to 2 respectively. So i.e. for every 1 blue, there are 2 yellow. Aryan takes at random 2 counters from the bag. Okay, so there are 2 stages or 2 legs to this question. The probability that she takes 2 counters of either color is 8 over 17. How many yellow counters did Aryan put into the bag? Okay, so let's create a tree diagram for this straight away. Okay, we have 2 different legs over here. So we'll create it as such, like this. Should be in the habit of doing this, in fact. Okay, there we go. So we'll have blue and yellow. We'll call this blue, yellow, blue, yellow, blue, yellow. Now, we don't know how many counters are in the bag altogether, but we do have a ratio over here. Okay, so we can create multiples of this ratio. So blue, we could say, if we add them together, we could say for every 3, let's say, counters, 1 would be blue. Okay, but we don't know if there are 3 counters. It could be a multiple of 3. It could be 3, 6, 9, 12, and we don't know obviously the numerator, what that would be, but we do know the fraction is a third. So what we could say, we could multiply them by x, 1/3 times x, and this as well times x over here as well, because they both have to be multiples of each other of this fraction 1 over 3. We end up with basically x over 3x, okay, or 1x over 3x. So this will be x over 3x over here, and similarly this would be 2x over 3x. It's very important to get the multiples of 3 over here because of the ratio. We don't know how many they are. That's different from a multiple. So let's go over here. Now we assume that we take out a counter and we throw it away. We don't replace it. So what would b be over here? Now we should know this process. This one over here, 2b's would be x minus 1, because we take away 1 from the numerator, over 3x minus 1. We always do the BB's and the YY's first. It just helps. This one over here would be 2x minus 1 over 3x minus 1. Let me do the BY now. So basically this would be 2x over 3x minus 1. It's 2x because it's still, we haven't used a y counter as such. It's still 2x from over here. And this b over here, this will also be, if we look at this one, we haven't touched this one over here. It'll be simply x over 3x minus 1. A way to check this, to get the same denominator, i.e. 3x minus 1 over here, the way to check these two are good. It would be x minus 1 plus 2x. That does give us 3x minus 1. They both add up to 1. Similarly over here, to get 3x minus 1, 1x plus 2x minus 1, let's give us 3x minus 1 snap. We're on the right track. All right, so we've got this. Let's move forward now to the next part over here. So now you want to actually apply this, and you want to do a few things. You want to find out either color, okay? Now either color would mean 2 combinations to us. It could either be this one, blue, yellow, or yellow and blue, okay? So let's hang on over here and look at the algebra involved in this. So B times W, let's do a blue and white, yellow counters over here. So this would be x over 3x times 2x over 3x minus 1. We'll put a bracket over here. This would give us, if we did this, 2x squared all over 3x and 3x minus 1. In turn, this would give us 2x squared all over 9x squared minus 3x. Now we know that the probability of getting by or yb, these two would be the same in effect, okay? So we could find out yb and add it onto this, or we could simply say, let's times this by 2, okay? So because these two combinations will always be the same, okay? by or yb, always, not just in this question, in any question. So let's do this to save time. We'll do times 2 over 1. This is non-calculator. We get 4x squared, top times top, bottom times bottom. This would be simply the same thing, 9x squared minus 3x. Now this thing should equal whatever we see over here, i.e. 8 over 17. Let's cross multiply now. I'm going to cross multiply this because we have two nice fractions. We can say this times this could equal this times this because of the two fractions and an equal sign. So we have 4x squared times 17. We have 68x squared equals 8 times 9x squared minus 3x. So let's go one step further. 68 squared equals, let's times these out, 72x squared, 8 times 3 minus 24x. Let's get all the x's on one side. So let's get a positive x squared coefficient. Hence, let's take the 68 squared over here and the minus 24 over here. So 24x equals 72x squared minus 68x squared. 24x equals 4x squared. So we can look at this now. There's no actual, we can't actually do this because they both involve x terms, okay, x and x squared terms. What we're going to do is this. We call it half a quad. Half a quad is when you have an x squared term and an x term. This could be written as this, 4x squared minus 24x. This is called half a quad. And what we'll do, we're going to now factorize this, okay? Factorize always a half a quad. 4x over here, x minus 6 equals 0. So if we could look at this over here, it's a bit squashed up, but from these two things, you can obviously see two clear solutions. If x is outside this, it'll be x equals 0, or x equals 6. So x equals 6 after all of that. The question is asking how many yellow counters did you put in? Yellow is over here. So yellow would be 2x, or 2 times 6, because x equals 6. The answer would simply be 12. So she had 12 yellow counters to begin with. You know, over 18. This would be 6 over 18 out of curiosity. You can always check the maths if you wanted to. You can plug in these numbers. You can plug in 12 into this. You would definitely get 8 over 17. So quite a tough question, but that's using algebra, and it's using the idea of conditional probability, or non-replacement, should we say. Most of these algebra questions involve non-replacement.